So now we're going to look at the kinematics, and now we're looking at test 2. So this is the second one. This one actually deals mainly with non-constant acceleration. And the way that you know it's non-constant acceleration is that if you have a look at the questions, straight away, you notice we've got t squareds. Wherever you see that, because the exam will not tell you it's non-constant, you need to recognize it. So when it's not constant acceleration, we don't use suvat, we use svar. Svar? I think that makes sense. So you differentiate, starts with a D, you differentiate down and you integrate up. And that's all you need to remember for these. So we've been given V and we want to find A. And it says it in terms of I, J, and K. Remember, S's are when we're in vector world. Okay, so we're going to differentiate that. Nice and easy. Bring that down. So we get 6t minus 12i plus 18t minus 3j. So we've got acceleration. And now it says when t equals 0, p is at the origin. That's quite nice because that's like your plus c. And you want to find r in terms of I, j, and t. So we've got v. We want to go to s or r, so we're going to integrate. So r equals, and we're going to get 3t cubed over 3 minus 12t squared over 2 plus 9t cubed, add 1 to the power, divide by the new power, over 2, j plus c. Now your c can have an I and a j in there. But because when t equals 0, all of that is going to disappear and r equals 0. The reason we know that is because at the origin, I can see c equals 0. So let's clean that up. So r is going to equal, that's going to cancel, that's going to become 6. So we're going to get t cubed minus 6t squared, I, plus, that's going to cancel, give us 3. And then we're going to get 3t cubed minus either 1.5 or 3 over 2t squared j. And then we get told at the instant when a equals lambda j, find the position vector. So we already found a, and remember for some things, it might be easier to write it in a column form. So we've got 6t minus 12 and 18t minus 3. And we're saying when this equals 0, lambda. So 0 i's and it's just lambda j's. So if we take the top bit, we've got 6t minus 12 equals 0. So t equals 2. And we want to find the position vector. So we take that t equals 2, stick it into our r. So we'll get 2 cubed minus 6 times 2 squared plus 3 times 2 cubed minus 3 over 2 times 2 squared. And that leaves us with minus 16i plus 18j. And that's question 1. Oops. Let's go here. So at time t equals t seconds, we've got a velocity, and we want to find the acceleration. So again, same thing as before, we've got svar, where we're differentiating down, but we're integrating up. We want to find the acceleration, so we're going to differentiate because we're going down. So a equals 6i, 5 times 3 over 2 is going to give me minus 15 over 2. 3 over 2 minus 1 is going to give me a half. But we know we want it when t equals 4. So if we sub in t equals 4, we get 6i, 15 over 2 times 4 to the power of a half, which is 2, is just going to leave us with 15j. And then we want the position vector, which is the same as our r, but this time we might have a plus c, because when t is 0, we're starting off somewhere. So now we're integrating this. So r equals 6t squared over 2, which gives us 3t squared. I'm going to write it in this form because I think it'll be easier for you to put your r in. And then add 1 to the power, divide by the new power is going to give us minus 2t to the 5 over 2 plus c, right? But we know when t is 0, p is minus 20 plus 20j. So we've got 3t squared minus 2t 5 over 2 minus 20 and plus 20. It's because we can plug our c in. Now we know when t equals 4, we substitute our values in. So 4 squared times 3 minus 20 gives me 28. And the other one gives me minus 44. And if you wanted to write it in the other form, although it wouldn't matter if you left it as a column. And you've got your position vector, so you've got your s when t equals 4. Okay, question 3. These are quite nice. As long as your integration and your differentiation is quite strong, and you recognize when t is not constant, so when it's squared or to the power of half or has any indice, it's non-constant acceleration. This is actually nicer, if you like, than regular SUVAT, where you have to think of directions and so on. So it's 4. When t equals 0, the velocity is 20i. We want to find the speed when t is 4. So we see speed, we're thinking, okay, we're going to need the magnitude in the end. But let's have a look. We've got a, and we want v. So we're going to integrate. When we integrate this, add 1 to the power. So 5t squared over 2i. A half plus 1 is going to give you 3 over 2. 15 divided by 3 over 2 is going to give you 10. And we've got a plus c. But we know when t is 0, so put zeros into everything, we get c as 20i. So our v equals 5t squared over 2i minus 10t to 3 over 2j plus 20i. We can plug in our t. So when t equals 4, v equals, so we can put 4 squared times 5 over 2 plus 20, which gives us 60, minus 4 to the 3 over 2 times 10, which gives you 80. And because you want the speed, you want the magnitude. So it's going to be the square root of the 2 positive bits, leaving you with 100 meters per second. Okay, next question. At time t seconds, where t is greater than or equal to 0, the particle p moves in the xy plane, that its velocity is given by that, right? So again, we can see, I know all of these questions are this, but in an exam, like I said, you wouldn't necessarily know. So you'd see that the t is not constant, so you'd write far down the side, and you want a distance, so you're integrating. So I integrate up, and remember when it's vectors, we normally call it r. Add 1 to the power, so we get t to the half, divide by the new power, that's going to become 2. Add 1 to the power, we get t squared, divide by the 2 gives us 2, plus c. We know when t is 1, p is at the point A. Okay, so when t equals 1, we're going to get r equals 2i minus 2j plus c. Yeah, we could put plus c there. And but we'll see the c's cancel out, so it doesn't matter. When t equals 4, r equals 4 to the power of a half, which is 2 times 2. So that's going to be 4i minus 32j plus c. So therefore the distance is going to be them taking away from each other. That's your point A, that's your point B. So A to B is going to be B minus A, which is 4 minus 2, so 2i minus 32 minus minus 2, which is going to give you minus 30j. But we want distance, not displacement. So we've got to find the magnitude of AB, square root it, and you get 30 squared plus 2 squared, square root answer gives us 30.06 meters. Okay, next question. A particle moves under the action of a single force F newtons. At time t, p is moving the direction of the vector I plus 2j, and the mass is 0.5. So we know F equals ma. Actually, we don't need that just yet. And we know Zahra, or R, that's an R too. So we're first going to find the value of t, because we're moving in the direction implies v. So if we've got the r, we're differentiating down. So v is going to be, bring that down, 3t squared minus 5i plus 10t plus 6j. And remember what we've said before, when something's moving in the direction, it means it's some lambda of that direction. So we know that v equals, if I write it as a column, 10t plus 6, is some lambda 1, 2. So we're going to get 3t squared minus 5 equals lambda, and 10t plus 6 equals 2 lambda. We can substitute 1 into 2. So we get 10t plus 6 equals 2 lots of 3t squared minus 5, which gives us 6t squared minus 10t minus 16 equals 0. Plug that into our calculators, and we get t equals 8/3. And now what we want to do is we want to find the magnitude of F. So F equals ma, so we need our A. We've got our V, we're differentiating down. So we differentiate again, and we get 6ti plus 10j. When t equals 2, we're going to get, so when t equals 2, we get 12i plus 10j. F equals ma, and we're told m is a half, 12i plus 10j. So that gives us 6i plus 5j, but we want the magnitude. Be really careful. When you see the word magnitude, underline it so you don't forget it. So magnitude is going to be the square root, 5 squared, 6 squared plus 5 squared, 61, which gives us 7.81 newtons. Okay, next. This is the last question here. Got it? That's it. Okay. Right. So again, we've got non-constant acceleration. So we've got differentiate down, integrate up. And we know what the velocity is. No, we were trying to find the velocity. So we're going to integrate. So v equals 1 becomes t minus 2t squared I, add 1 to the power, divide by the new power, 3t minus t cubed over 3j plus c. We know when t equals 0, all of that becomes 0, so it tells us that our c equals 36i. So when t equals 4, v equals, and if we sub it in, we'll get 4 squared is 16 times 2, 32, 1 minus 32, but then we've got this plus 36. So we're going to get 8i minus, you can just start in your calc, 28 over 3j meters per second. And then it says find the value of t at the instant when it's moving perpendicular to I. So let's think about what that means. That's I and that's j. If I'm moving perpendicular, I'm moving like this, right? So I'm moving at right angles. So essentially, my I component, so it's actually I is actually this bit here. along this whole line, my I is 0. So if it's perpendicular to I, I've got to equate the I component to 0. So let's think what the I was. The I was t minus 2t squared, and then we also had 36. I'm going to make that equal to 0, sub it in my calculator, and t equals 4.5. Then it says at time t seconds, q moves, so this position vector is given by, find the value of t at the instant when the speed of q is 5 seconds. So we've got the r, and we're trying to find speed, which is essentially the velocity, so we're going to differentiate it. And this is a totally different particle, we don't need the p, so let's scroll up and do that bit. All right, so let's differentiate it. We get v equals 2t minus 1i plus 3j. And we want the speed being 5, which is the magnitude, which means taking your I component and squaring it, your j component squaring it, square root it gives you 5. I'm going to square both sides. 25. I'm going to open that out. Put everything on one side. So we'll have, and I'm going to stick it in my calculator, solve it, and I get t equals 2.5. So although these don't seem as nice on first glance, they're actually nicer almost than some of the SUVAT questions. Okay, so that's the kinematic test 2. Can't remember how many they are. I think there's 4 of them, but we'll work through those. I'll try to get through all the mechanics today, and maybe some of the stats tomorrow.